Okay, Algebra 2. I am home with a sick kiddo today, so I am recording this lesson and sending it to you. You should have 3 pieces of paper in front of you. So this first one looks like this. It's the 4 quadrants, and then you have the actual notes for 3-4, and then you should have the homework assignment for 3-4. So I'm going to start by just kind of skipping around all over the place. We're going to do a greatest common factor, and then we're going to go down here and we're going to do a couple more from the 3-4 homework assignment, and do a couple more of the greatest common factor. Then we're going to move on to the next box to the difference of squares, and then we're going to kind of go that route. So be prepared to skip around a little bit while we're doing this, and have all 3 of those sheets of paper handy with you, okay? All right, so greatest common factor is the first one that we want to start with, and we've done this. This is all about factoring, so we're using these 4 factoring methods to break quadratic functions or bigger polynomial functions down. And we've done this before. We did this in chapter 0. This is like the 3rd time maybe we've seen this. We'll see this again. You know, if you've already learned this stuff, then you'll just be set to go, okay? Starting with greatest common factor, we want to be able to pull something out. So we're looking at all 3 of these pieces, and we're just saying, like, what do each of those have in common? So just starting by looking at the number 2, 6, and 8, I see that all of those are divisible by 2. But then also, in addition to that, each one of those has an x that I can pull out in front, okay? And so when I pull it out in front, I don't throw it in the trash. I just leave it there, and then we write what's left over, okay? So if I take a 2x out of the 2x cubed, the 2 will be gone, and one of these x's will be gone, but there'll still be an x squared left over, okay? Then I do plus, because that's this symbol. 6 divided by 2 will be 3, and if I take one of these x's away, I'll still have an x, right? And then it's kind of good to just like mental check, like 2x times 3x. Does that come out to be 6x squared? Yes, it does, so we're good to go, okay? Then minus, because that's this symbol right here, and then if I take 8x and divide by 2x, I'll have 4, and the x is gone, so this is completely broken down by using the greatest common factor method, okay? All right, so let's go down to your note sheet really quick, and let's look at a couple greatest common factor. I'm going to skip to example 2. So go to part A. Let's do a greatest common factor here, and in this case, they have it set equal to 0. So note that we're gonna be setting it equal to 0 at the very end. All right, so 16x squared plus 8x. I notice that they're both divisible by 8. And I can take an x out, okay? And when I do that, 16 divided by 8 is 2. And I took one of these x's away, so I'll still have an x left over. Okay, now this is the very, very most important thing. I'm going to put this in a different color so you can remember this, all right? 8x, if I take 8x out of it, it's like completely gone, but you can't just leave it blank right here. You have to put a plus 1, because imagine that I'm going to like multiply that back through. 8x times 1 will give me 8x, but if I left like a 0 there or a blank or something there, then I wouldn't get this 8x if I multiplied it back through. So you have to have a 1 in that spot, okay? So this is what we have going on here, and we're going to set those equal to 0. Okay, so now I kind of have 2 chunks. I have this 8x chunk, and I have 2x plus 1 as a chunk, okay? So 8x, I'm going to set him equal to 0, and I'm going to set 2x plus 1 equal to 0. And if I take the 8x equal to 0 and I divide by 8, 0 divided by 8 is still going to be 0, so I have x equals 0. And then over here in this 2x plus 1, I would subtract the 1 over, there's supposed to be a 0 there, 2x equals negative 1, and then I would divide by 2, and x equals negative 1/2. You can write it as a decimal if you want to, but that's that, okay? And what we're solving for here, if this was a quadratic function to start with, so we know he looks like a parabola, and you don't have to sketch this if you don't want to, but what we notice though is like 0 is one of the solutions that's here, and negative 1/2 is a solution right here, and that's what's happening to my parabola, is that he's crossing at those 2 places, okay? So that's kind of what we're solving for when we do these, okay? Just do one more example of that, part B. If I'm looking at those 2, 21 and 14 are all divisible by 7, and I can take an x out of each one of those. So if I take a 7x out of, just deleted some stuff. If I take 21 divided by 7, that is 3. And if I took one of these x's out, I'll still have an x left over, okay? If I take a 7 out of that 14, I'll end up with negative 2. And the x is gone, so he's just gone. And now I set them equal to 0. So starting with 7x equals 0. And then over here, I'll have 3x minus 2 equals 0. And to get that x by itself, divide by 7, x will be still equal to 0. 0 divided by 7 is still 0. And then over here, I would add the 2. 3x equals 2, and then divide by 3, so x equals 2/3. And that's what he would look like. So again, those are the two places where he's going to cross at 0, and again at 2/3, so he'll look something like that, okay, is what that parabola will be. All right, if I'm going too fast as I'm going through these, please feel free to pause, rewind, rewatch, whatever you need to do, okay? All right, so that was the greatest common factor method. We're going to go back up to our 4 boxes here, and let's go to the next method, which is the difference of squares method, okay? And this one, they do have a graph for me to draw. So after we found our solution, we're going to plot those and see what we get, okay? So a difference of squares. This is my favorite of the 4 methods, and the difference of squares, there are 2 things that need to take place. First of all, you need to have a difference, so you're subtracting. Okay, so like here I'm subtracting between 2 things, and the second thing that needs to happen is that you have to have 2 numbers that are perfect squares. Perfect, I can't spell. Perfect squares, okay? Like here, the numbers that I have are 16 and then 64, okay? And so a difference of squares will always break down into 2 little lumps that look like that. So I start off with that, okay? And then I look at the first piece, and I look and I say, what is the square root of 16x squared? The square root of 16 is 4. And the square root of x squared is just x. So I have a 4x, but I'm also going to put a 4x over here. So it's 4x and 4x. And then I do the square root of 64, which is 8 and 8. And one of them is plus and one of them is minus, and it doesn't matter which one you do. Now we have him completely broken down as a difference of squares, but the last thing that I want to do is I want to make sure we set him equal to 0, so we solve. So 4x plus 8, we're going to set that equal to 0, and 4x minus 8, we're going to set that equal to 0, okay? So I'm going to subtract the 8 over, and 4x equals negative 8, and then divide by 4, and negative 8 divided by 4 is negative 2, okay? And then over here, you're kind of going to probably notice a similar pattern because we're doing the same thing. 4x equals 8, divide by 4, x is going to be positive 2 in that case, okay? So here, what's happening is I have positive 2e's crossing and negative 2e's crossing, and he's going to be a parabola that looks something like this, except he's going to actually be really a lot further down than that, because if you look back at our original function, my y-intercept is going to be negative 64. So he's actually hitting down here at negative 64, even though this is 2 and negative 2. So my graph is not drawn to scale, but that's kind of what he will look like, okay? So when we were factoring him, we were trying to find those zeros, or trying to find where they cross, okay? Let's go down to the notes, and let's do a couple more difference of squares. So let's go down to, hopefully you can see where I'm at here. Let's go to example 3, part B, where it says x squared equals 64, okay? Now you could solve this by just taking the square root and doing that thing, and I'll show you that here in a second. But what I'm going to do first is rather than taking the square root, I'm going to move the 64 over here by subtracting 64. So I have x squared minus 64 equals 0. And now I have a difference of squares, okay? And I'm going to break him down into the 2 pieces that we have, okay? So I have the square root of 2, or excuse me, the square root of x squared. The square root of x squared is just x and x. And the square root of 64 is 8 and 8. And one of them is plus and one of them is minus. And then I'm going to set them equal to 0. So x plus 8 equals 0, and x minus 8 equals 0, okay? And if I do x plus 8 equals 0 and I subtract the 8 over, that means x equals negative 8. And over here, if I add the 8 over, then that means x equals positive 8. Okay, so those are my 2 places where he is crossing, okay? When you have just x plus 8 and x minus 8, it's really nice because you can just go you don't necessarily have to do all this work that I did right here. If x plus 8 equals 0, x equals -8, and if x minus 8 equals 0, x equals +8. It's just like flipping the sign here when you are setting them equal to 0. So that makes it kind of nice. Now, let me go back up to the way that you wanted to do it probably, which was just taking the square root. So the square root of x squared and the square root of 64, okay? The square root of 64 comes out as 8, but if you do it that way, sometimes you will forget to put the +8 and the -8 to get two answers, because technically the square root of 64 is not just 8. If we inserted the square root in there, you need to make sure you have a plus and a minus, right? Because when we insert the square root in there, we're like saying, what do you take times itself to get 64? Well, 8 times 8 is 64, but -8 times -8 is also 64, okay? So that's one other thing that we have to take into consideration. So that is a difference of squares. And I'm not going to do example C. We'll skip that. Okay, so there was an example of a difference of squares, right? Pretty straightforward. I'm not going to bore you too much with doing too many repetitions, okay? Let's go down to the next one, which is a simple trinomial. And things with a simple trinomial is this will always be 3 terms or 3 pieces. You might want to add that to the difference of squares. There's one other thing up here. So we said subtracting, we said 2 numbers, but also this will only ever be 2 terms or 2 pieces for a difference of squares, versus simple trinomial will be 3 pieces. And that's what the word trinomial means. Tri means 3, okay? So 3 pieces. I'm going to draw an arrow to that word tri, okay? Trinomial, okay? And it's simple because it's just x squared. There's like no number in front of here, okay? No number, I'm going to say other than 1, because if there is no number, we assume that it is 1. Other than 1, okay? If there's no number in front of an x squared, then we assume that it is 1. So this is a simple trinomial because it's 3 pieces and it's just x squared. There's not a number here, so we assume that it's kind of like an understood 1, okay? Versus, let me go over here and compare it to a complex trinomial. Complex trinomial is 3 terms, but he has a number in front of the x squared, and that just makes him a little bit harder to do, okay? So number in front of that x squared, that's how he's a complex trinomial, okay? So if you're factoring down stuff and you can just at least figure out which one of these 4 it is, that's half the battle, okay? All right, so let's go to factor this simple trinomial down. And simple trinomial breaks down kind of like a difference of squares. So you start by just drawing those 2 bumps, and then the strategy for simple trinomial is you just look at this number and you look at this number. And this number is the number that we want to multiply for, and this is the number that we want to add for, okay? So we're multiplying to get 14, and we're adding to get -9, okay? So sometimes it helps to list out the multiples of 14, like 1 and 14, or 2 and 7, and I think that's all for 14. That's the only multiples, okay? So which one of those combinations will give me -9 when I add them? Well, it will be 2 and 7, except I need to have a -2 and a -7, okay, in order to make -9 when I add them, okay? So that's all I have to do, except I have to write it as x minus 2 and x minus 7, okay, to be those 2 bubbles. And that's factoring down my simple trinomial. You can check your answer really quick just to see, does -2 times -7 give you +14, and -2 minus 7 gives you -9? Yep, it does, so we're good to go. And then we just set them equal to 0. So if x minus 2 equals 0 and x minus 7 equals 0, these ones are really nice. You can just flip the sign, like adding 2 and adding 2. X would be +2, right? It's just the opposite of this guy. Here, x minus 7, the opposite would be x equals +7. So that's just where those 2 things are crossing. So at 2, he's crossing, and at 3, 4, 5, 6, 7 is another place where he's crossing, and he's doing one of these, something like that. Okay, so that's where my parabola is. These are the zeros of my function, where my parabola is crossing. Okay, let's go down and do a couple more simple trinomials. So let's do like this one, part A. Okay, he's a simple trinomial because he has 3 pieces and it's just x squared. So we're looking at this number and we're trying to multiply to get this number, but when I add them, give me 6. And I'm trying to think. I'm trying to think. Maybe I have a typo. I think this is supposed to be 16 instead. Add a 1 in there because I think I remember this being a typo because I don't think we can add it and multiply. Okay, so that's supposed to be a 16. Add that 16 in there. Add that 1 in there. Okay. All right, so multiplying to get 64. 64 would be like 1 and 64, or 2 and 32, or 3 doesn't go in there, or 4 and 16, or 5 doesn't go in there, 6 doesn't go in there, 7 doesn't go in there, 8 does go in there, 8 and 8, okay? And I think those are the only 4 combinations that will give me 64. So I am wanting the combination that adds together to give me 16, and you can probably figure out that that is 8 and 8, okay? So I draw my 2 bubbles, and all I have is x plus 8 and x plus 8, and that's how I factor him down. And I set them equal to 0. So if I set x plus 8 equal to 0, that means x equals negative 8. But same thing happens with this one. X is also going to be negative 8. So this one's kind of a weird one where we have the same number, and we only have like one number basically, because negative 8 and negative 8 are the same number. We only have one number, and we only have one place where he crosses. So kind of think about in your head like what that might look like. If this is the only place where he's crossing, what he's probably doing is doing one of those, where the vertex is at negative 8, okay? So he's only touching at one place. And that's kind of how that guy looks like, okay? Let's see, do we have any more simple trinomials? There's this one, but I'm going to skip it because I think we're good to go on these, okay? I think we're pretty well set, okay? Let's go up to the nasty one. The complex trinomial, okay, has 3 terms, but that 2 in front makes them complicated, and there are steps to this one. This one's the ugliest of the 3, okay? When we did chapter 0, I gave this complex trinomial to you as a bonus question, and I was pleasantly surprised because there was quite a few of you who were able to get that done successfully. Now, the complex trinomial, when we do it in this chapter, is not bonus. I will give you questions on a complex trinomial on the test that you have to do, not for bonus. Okay, so be prepared for that. This time you actually have to know how to do it. All right, so here's the steps. Step number 1, multiply the a and the c, which is the 2 and the negative 10. Okay, and so when I do that, 2 times negative 10 is going to be negative 20, okay? And then what I do is I look at multiples of negative 20, like 1 and 20, 2 and 10, 4 and 5, I think are the only multiples, okay? And each of those has to be negative in order to make negative 20, but we'll get to that, okay? And so I'm wanting to multiply to get negative 20, but when I add them, give me this number, and there is no number in front of that x, so we assume that it is 1, all right? So which one of these combinations will give me a positive 1 when I add them together? And it's going to be this guy. So what I have to have happen is that this 4 is going to be negative, and the 5 is going to be positive, okay? So that's step number 2, is choose your numbers. And then step number 3, I'm going to write in 4 pieces. Okay, I'm going to write my trinomial, my 3 pieces, in 4 pieces now instead. Okay, so here's my 4 pieces. The 2x squared is going to come down, and he just stays as 2x squared. And the negative 10 is going to come down, and he stays negative 10. Okay, but then this guy is going to break into 2 pieces, and his 2 pieces are going to be these two, minus 4x plus 5x, okay? Now, if you switch these 2 pieces around, that's not a problem. It's okay. Your middle steps will just look different than ours, writing them this way, but your ending step or your final answer will look exactly the same, okay? And then the last thing that we do, step number 4, is factor by grouping. Factor by grouping. Factor by grouping. Okay, so we're going to group those two, and then I kind of do this greatest common factor thing. So looking at this thing, I can take out a 2 and an x, okay? And if I take a 2x out, I will have x minus 2 left over. And if I take, let's see, I want to take a 5 out of there, and left over is x minus 2, okay? And at this point, I always say, you know you did it right, because this piece and this piece will end up being exactly the same. Okay, so x minus 2, I yank him out of there, but I only write him once. I only write him down once. And then left over is 2x plus 5. 2x plus 5. Okay, then I'm going to set those guys equal to 0. We're almost done. We're almost done. Set them equal to 0. So if I have x minus 2 equal to 0, x will be equal to positive 2 if I add him over. And if 2x plus 5 equals 0, let's subtract the 5. 2x equals negative 5. Divide by 2, x equals, and negative 5 divided by 2 is negative 2.5. If you want to write them as a decimal, you can. Whatever. Okay, I hope I'm not going too fast. If I am, please pause. So we've got a 0 at 2, and we've got 1 at negative 2.5, which is this guy here, and something like this is happening. Ugh, that was a very bad drawing, but whatever. Okay, he's touching down here at the y-intercept, which is negative 10, and that's what my parabola looks like. Okay, let's do one more example of complex trinomial, and then I'll let you go. Okay, so complex trinomial. Let's answer this story problem down here. Let's do this guy. Okay, solving equations by factoring. The height of a javelin is in feet is modeled by this function. Okay, so this is a parabola where since that's a negative 16, he is doing one of these, and the javelin is going up and he's coming back down. So this is like that projectile motion that we've talked about before. And we're trying to figure out where t is the time in seconds after the javelin is thrown. How long is the javelin in the air? Okay. So basically we're trying to find the length of this, and we're trying to figure out how wide that parabola is, or how long that is, okay? So where t is the time in seconds. Okay, so we're going to factor this thing down, and this is a complex trinomial. Whew. So we're going to start by taking a times c, so negative 16 times 5, and negative 16 times 5 is like negative 80. And then I want to multiply to get negative 80, but when I add them, give me a positive 79, okay? And my first option is always to do 1 and 80, and I think that's the combination that we actually want, okay? So I want a positive 79, so that means the 80 has to be positive and the 1 has to be negative, okay? So I'm going to erase all my junk here, and then we're going to start to break them down. So we're going to write them as 4 pieces. So we start with negative 16t squared, then we go plus 5, and this guy's going to separate into the 2 pieces. So minus 1t plus 80t, and then we factor by grouping. So we group and we group. Oh, my kiddo has a bunch of coughs. Oh, there's some more. Malia. She's not even my sick one. Malia. You okay, honey? Do you need some water? Oh, no, she's mad because she's sleeping. Okay. All right, so in this first chunk, we're going to take out a, let's do this. Let's take out a negative 1. And is that what I wanted to do? Yeah, taking out a negative 1. So we're left with negative 1t. I'm going to take out a t also. So left with is 16 plus t. Okay, I'm all screwed up. Let me start over. Let's take out a negative t, and left over is 16t plus 1. There we go. That's what we want. Okay. Then here, let's take out a positive 5, and left over will be 16t plus 1. Okay. Then my 2 pieces are 16t plus 1 and negative t plus 5. Okay. Then I set them equal to 0. So 16t plus 1 equals 0. And negative t plus 5 equals 0. Okay, so really gross stuff, but that's okay. We're going to get to the answer. If we subtract the 1, 16t equals negative 1, and divide by 16, t is going to be negative 1 over 16. Okay, then over here, if we subtract the 5, negative t will be equal to negative 5, but then if we divide by negative 1, I guess, negative 1, t will be equal to positive 5. Okay, now remember from the story that we were solving for time, And over here we got time as a negative 1 over 16, but time cannot be negative, so we can just conclude that this javelin is spending 5 seconds in the air, and the time is 5 for that. Okay, so this is just kind of an application of why we would want to solve and find those zeros. So I kind of like that problem. But on your homework assignment, you're going to want to probably make sure you have this handy, at least for that complex trinomial. Those steps, that will be super helpful. But these are the four methods that you have. Oh, shoot, there's one more thing. One more thing that I want to add. Example 1. Go to section 3-4. Example 1. These are the notes. Okay. One more thing. It says write a quadratic equation in standard form that has -3 and 2 as its roots. I changed those numbers so that they're really not disgusting numbers. I want them to be really nice numbers, so -3 and 2 as its roots, okay? In all of these other trinomials, they were starting us off with an equation. They were having us break it down and find the two answers. And starting off with an equation, break it down and find the two answers. Okay, but now they're giving us these two answers, and they're wanting us to put it back into a quadratic function. So here's an example of that. Okay, what I'm going to start with is I know that my roots are -3 and +2. So that means x equals -3 and x equals +2. Okay, now the next step that I go to is what would they have looked like if they were in the parentheses, okay? And we kind of talked about this before, but in the parentheses, we flip the sign, right? Like if x equals -3, x would be, or x plus 3 is what it would look like in parentheses. Here it would be x minus 2, okay? Then I'm kind of working backwards, and rather than breaking this down, I take what I have broken down and I'm going to FOIL that out and get an answer, okay? So this is going to be like the FOIL method. We're going to take these two functions here, we're going to FOIL them together and come up with a quadratic equation, okay? So in the FOIL, I take x times x, which is x squared. I take x times -2, which is -2x. The inside pieces are 3 times x, so that's +3x. And then the outside pieces are, or the last pieces are 3 and -2, which make -6. And then the last thing I'm going to do is put these two like terms together. So x squared, he can just chill out, but -2x plus 3x would be +1x and then -6. And this is my quadratic function that has those two things as roots, okay? So you start with those two pieces, make them into the parentheses that they were in, FOIL it out, and combine like terms. And this is writing an equation in standard form that has roots that are -3 and 2. There you go. Okay, so on your homework assignment, blah, 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 that's a lot of stuff. These first 4 are going to be like that last example, okay? I'm going to go ahead and have you guys do all of these. There's 18 problems. That's a lot. Whew. But hopefully you've got a lot left in the period that you can get these guys done. What would probably be beneficial to do first is to go through and label them. Like number 5, I'll give you a little hint. He's 3 pieces, so that's a trinomial, but it's just the m squared, so there's no number in front, so he's a simple trinomial. So like going through and just labeling each one of these and solving them, you know, like maybe go through and label all of the difference of squares and solve them all together, you know. That would be a really good idea. In 5 through 8, they notice that they don't say equal to 0, so you can just break them down and just leave them, versus down here, they are set equal to 0. There is an equal sign, so you will have to set them equal to 0 and solve for them, okay? All right, so hopefully that is it. If you have any questions, let me know. Otherwise, we can go through questions tomorrow as well. Hopefully I'm back by then. So good luck.